In this video, we will be reviewing some properties of exponents as well as learning about negative exponents and the exponent of 0. But let's go back to the basics. What is an exponent? Well, first of all, an exponent has to be associated with the base. So here, 5 is the base and 2 is the exponent. Now sometimes we call that exponent the power. So what does 5 squared mean? Well, hopefully you remember that means 5 times 5, which is 25. So we have a base and we have an exponent. Let's talk about negative exponents. What does 2 to the negative 3 mean? It does not mean negative 2 times negative 2 times negative 2. No, no, no. In order to evaluate negative exponents, you have to make them positive. So how do you do that? You want to take the reciprocal of the base. So if the base is 2, the reciprocal would be 1/2. And you then change the sign of the exponent. So since it was negative 3, now it's positive 3. So 2 to the negative 3 means 1/2 times 1/2 times 1/2, which is 1/8. Let's look and see how could those negative exponents be used if you have some letters. Well, first of all, notice that this has a positive exponent that has a negative exponent. So let's just keep that fraction. Keep the positive exponents where they are, and if a negative exponent is on top of a fraction, the reciprocal would bump it to the bottom, change that sign. Now remember, just like here, reciprocal of 2 was 1 over 2, so the reciprocal of x would be 1 over x. And notice I changed the sign of the 2. Right here, this is on top, it needs to go on the bottom, taking the reciprocal, making that x to the positive 3. This is on the bottom, which would be like 1 over y to the negative 2, so we flip it, that comes upstairs, and we change that to y squared. So when you're looking at negative exponents, if it's on the bottom of a fraction, pop it to the top. If it's at the top, bring it to the bottom. Now what does that 0 exponent mean? Well, 5 to the 0 power, x to the 0, this all equals to 1. Anything except 0 raised to the power of 0 equals 1. Now you might ask why. Well, I would like to show you why. So let's say you have 5 to the 3rd power divided by 5 to the 3rd power. You might remember the rule, if you have the same base being divided, you'd keep the base, but what do you do with those exponents? You subtract them, which would be 5 to the 0. Well, let's go back. 5 to the 3rd over 5 to the 3rd. You also remembered when you divide something by itself, it goes in there one time. So that's why 5 to the 0 power equals to 1. So again, that 0 power is not 0, but it's 1. So let's see how can we apply some of the rules that we've learned in previous math classes with negative exponents. So in this exercise we will be evaluating, meaning we're going to get numerical answers. We won't see variables. So let's look at number 1. 2 is the base. It's the same base, so we can keep the base. And what do we do with those exponents if we're multiplying the same base? We would add them. So that's 5 plus a negative 2. So that's 2 to the 3rd power, which means 2 times 2 times 2, which is 8. So notice I did not take the reciprocal. I went ahead and just used my rules of keep the same base and add the exponents. Let's look at the second example. I want you to identify the base. What is the base? The base is 5. Not negative 5, but just 5. So what this really is negative of 5 to the negative 4. So we have negative. Now I'm going to take the reciprocal of the base, which would be 1/5, and raise that to the positive 4th power. That means negative 1/5 times 1/5 times 1/5 times 1/5, or in other words, 1 to the 4th power and 5 to the 4th power. But notice that negative is still lurking out in front. It's not going to go away because we only have one of them. So we multiply all that together. We get 625, We multiply all the ones and we get 1, but the answer is negative 625 because again, the base was just 5. So let's look at problem number 3 and kind of compare it to problem number 2. What is the base on problem number 3? It is negative 2 because of those parentheses. So we can take the reciprocal of that base, which would still be negative, and then change the sign of the power. Right? So this time we're going to have a negative raised to the 4th power. So that's 4 negatives in a row. Negative times negative times negative times negative. So I know my answer is positive. 1 to the 4th power is 1. 2 times 2 times 2 times 2 is 16. Now usually we don't put that plus sign, but I wanted to emphasize that yes, the base was negative 2, so we still had the negative, but because we have an even amount of negatives being multiplied together, that's why it's positive. A little confusing, but just identify that base. So as we look at the next problem, we can compare these side by side. All right. On this one, the base is negative 5. Here, the base is positive 5. So again, we want to take the reciprocal of the base, and yes, that stays negative, and we change the sign of the exponent. So this would be negative 1/5 times negative 1/5, which of course is positive 1 over 25. But here, the base is only 5, so I'm going to keep that negative, take the reciprocal of the base, which is 1/5, change the sign of the exponent. So here we have negative 1/5 times 1/5, so it stays negative. Be very careful about that because I guarantee you it will be on the next test. Now let's start getting a little bit more complicated. Do we have any rules about exponents being subtracted, like bases being subtracted? No, we don't. We only have rules of when the same base is being multiplied, or the same base is being divided, or we have a power raised to a power. So this fits any of those categories. So let's just kind of go order of operations. We need to do exponents before we subtract. But because we have negative exponents, we have to change them to positive. So again, the base is 3, so I have 1 over 3, change the sign of the exponent, minus the base is 3, change the sign of the exponent. Now what's 1/3 squared? That's 1 squared is 1, 3 squared is 9, and then this is just 1/3. So now we go back to about 4th, 5th grade math, find a common denominator, which is 9. So that stays 1/9. Here we multiply by 3 over 3, and that's going to be 3/9. So 1/9 minus 3/9 is negative 2/9. It's not that hard. Don't be afraid of the fractions. Now look at number 7. Notice it's problem number 6 on the inside of the parentheses raised to the negative 2. But let's say you hadn't done problem number 6. What would you have to do? Work inside out. There again, you cannot do anything with those exponents except follow the parentheses. So as I follow the parentheses, I would do exactly what I did on number 6. I'd have 1/3 squared minus 1/3 to the 1st power. And I'm going to have to take care of this after I do inside the parentheses. Now since I've already done that on problem number 6, I'm going to kind of skip some steps and just put that answer here. So I know that's negative 2/9, but that's still raised to the negative 2 power. Now I'm going to do something. How do I make that exponent positive? Again, take the reciprocal of the base. Stays negative. The base flipping, taking the reciprocal of the base does not change its sign, but I am going to change the sign of the exponent. So we have 9 squared, 9 times 9 is 81, and negative 2 squared. Negative 2 times negative 2 is positive 4. Now what if you didn't put that negative with the 2, you put it with the 9? It's still positive because it's squared. A negative times a negative is a positive. Let's look at that last example. Look at all those 5s. Now you would think we could do something, but no. Again, we have addition, so we have to just go from left to right. So what's this base? Just 5. So I'm going to keep that negative, take the reciprocal of the base, change the sign of the exponent. Plus. Now what's anything raised to the power of 0? I heard you, 1. Plus, that's just regular old 5. Well, let's add together the stuff we know how to add together. Now 1 plus 5 is 6, right? Okay, and that's negative 1/5. So again, finding a common denominator would be 5. So that stays negative 1/5. Remember, put that over 1. So I multiply both of those by 5. So I have negative 1/5 plus 30/5 is 29/5. They look scary, but they really are easy. It's just a lot of arithmetic, making sure you know how to change negative exponents into positive exponents.